Okay. So, to my big surprise, the reach of the organizers of this conference is so enormous that they took care that, I think this Monday, The Economist had a special issue on the rise of robotics, which is, of course, very nice. To start with, I took this cartoon from the special issue, and as you can see, The Economist thinks that as soon as you are not independent, sick, a baby, or elderly, then you can have these sort of robots. Would you think that these robots are embraceable? Would you like to be embraced by these robots? This is one of the questions that I want to ask. To what extent are robots embraceable? And I think this is an important question because it relates to the question about the difference between robots and humans. I'm particularly interested in something that has recently come up, I think. I didn't see anything about it in the special issue, and that is soft robotics. Now, this is a soft robot, but actually it's not a very smart. It's just a cuddly thing that simulates breathing and heartbeat, has a little bit of learning capacity, but it's just a toy. What I want to discuss is the difference between what I've called iRobots, in the sense of information-driven robots, which is actually, of course, data-driven robots, and what I've called M-robots, and that is morphology-driven agency, robots with a morphology-driven agency. I'm going to come back to what that means. And then if Shanti allows me, if I make enough progress, then we can look at what the combination of these two types of agency in a robot will mean for our privacy and how we might begin to reinvent that. Now, my research, as Shanti already said, is a research in the implications of smart environments, or predictive analytics in general, on democracy and the rule of law. As Mark Weiser said somewhere in the 90s, prophetically, we're moving towards something called ubiquitous computing. That means that there is a hidden complexity below the surface of things. You can throw the keyboard out to a large extent as the interface, and the environment begins to adapt to your assumed, inferred preferences. Somebody even called this the everywhere, W-A-R-E. So the idea of the Internet of Things, that all things go online, are interconnected, and because they have access to what I've called big data space, they can tap into this big data space and search and do machine learning, artificial intelligence, new style, and make inferences from that. At this moment, our online environment already works that way. Think of the search engines, behavioral advertising, autocomplete, the recommendations of Amazon.com, customer relationship management, study of your like behaviors, how you like, push the like button, called herding behaviors. This is about when you see a site with 500 likes, people can study whether that has an influence on whether you are going to like that site also. And this relates to A/B research. I want to briefly explain that because this is something that robots at some point will do with you. At this moment, it works online. So there's a website, and whoever is paying for this website wants to know how to make it more profitable or other purposes that the organization has with the website. So he changes one little thing on the website, and he calls the normal site A and the new one B. And then he starts measuring the behavior, clickstream behavior, on the two sites, figures out which is the behavior he or she prefers, and changes the website to B. So you have a social science experiment with a full population, because the people coming to the website, you divide them into these two groups. And you can experiment with people, and you can figure out how best to make the website such that they behave in the way that you want. Basically, you could say that this is the idea of ambient intelligence, how to preempt our intent, how to cater to preferences that you have not yet become aware of. Now, what's interesting here is the idea of data-driven agency of our environments. What's agency? What's the difference between an environment that consists of things and an environment where there is some sort of agency? Now, an agent is a unity of perception and action. That means sensing the environment and acting on the environment and sensing how its own behavior implicates the environment. And if that agency is data-driven, it means that it's based on digital representation, based on knowledge discovery in databases, machine learning, neural nets, genetic programming, etc., etc. Now, I'm sure you all know that the whole idea of big data that I'm drawing into this discussion is becoming sort of quasi-religious and mythical. I liked very much that somebody finally sat down to investigate whether the idea that Google can actually predict flu is correct or not. And when you do the real empirical research, you see that it is not correct. Okay, so now we have environments that have agency characteristics. The agency is beneath the surface. It's invisible. It's sort of software-ish. But can you hug a computer system? I was going to talk about embracing robotics. No, you can't. So let's move on to a robot, because here you have an agent that seems to fit into an entity other than an environment. And I want to look at the move from a robot as a central processing unit, as a standalone device, where the idea is that the embedding of the robot, so the body, is just a matter of implementation. I'm a legal philosopher, so I look at this from the perspective of political philosophy. You could say that this is the old idea of a central processing unit that is in control, a sovereign, and the rest, the body, is just implementation. The body is a set of subjects. That means that the central processing unit is mapping reality by means of course, digital representation, and the body is actually a source of perturbation. The old idea that I now described, means that the mind of the robot is in the non-biological skin bag, as Andy Clark has called it. We now see the move to something else, the move to cloud robotics, because that's where the real intelligence is. You see an extended mind for the robot that is continuously tapping into the digital unconscious, as some people have called it. Look at Deep Blue, Watson, but also Google Car or robots like the iCub. They are intelligent, they are functioning, they are smart because they can tap into big data. Now, what's the difference with morphology-driven agency? Let's look at things like soft and evolutionary robotics. I said in the beginning that the special issue of The Economist doesn't look at this at all. That's very interesting. Actually, they say, I cite them, that problems restricted to the world of data are much more tractable than manipulating things in the real world. That is 100% opposite to the findings of morphological computation and soft robotics. What happens there is that instead of having all the movement of the robot pass through the central processing unit, through the rational modeling of reality, which gives you the robot with what we call robotic movements. You look at the body of the robot. You take the body of the robot to do direct computations of the environment, so not a digital in between. So there's no representation, no digital representation. And it turns out that you can use the design of the robot to make it use so fluently that I think there was a robot fish that went viral over YouTube that can swim as fluid and fast in a school of fish as the real fish. So this is something totally different than the old style artificial intelligence. So it's not about the brain as the central control unit. It's about the idea that it's not just that the brain or the computational digital center of the robot steering the body. It's about the other way around. And maybe this is a nice way to sum that whole idea up. It's something that occurred in the New York Times this week or last week. It turns out that if you give a person that is depressed a shot of Botox over here, where you have these thinking wrinkles, and you see what happens in the course of, I think, 2 or 3 weeks, then it turns out that this change in the body of the depressed person has a real effect on depression. So I find this not surprising at all. This is the body shaping the brain. It's a wonderful example. Now, there's a wonderful statement in an article on morphological computation by Hauser et al. Saying the body doesn't seem anymore as a device deemed to merely drag the brain around. Old-style robotics sees the body in that way. But now we come to the issue of privacy. I have exactly 1 minute for that, so that's very good because these are more questions. Oh, 2 minutes. These are more questions than answers. Now, imagine a robot. If that robot is in any sense smart, it will be cloud robotically steered. It will tap into this digital and conscious, into enormous amounts of big data. Now, what if your robot, your companion robot, your care robot, whatever, what if it does some A/B design on you? Testing your moods, your susceptibility to spending behaviors, to voting behaviors, or any other behavior. And I'm purposely using this term, behavior, which is a computer science term, because a computer doesn't think in terms of action, but in terms of behaviors, measurable, the digital in between. Now, what if your robot is continuously online, sharing its observations of you, its measurements of you, with its peers, to improve the user experience? If you go online and you go to a website, look at the terms of service that you are supposed to agree with, it will always say that after using your personal data, your clickstream data, etc., after the purpose has gone, that they are going to keep it to improve your user experience. The same will definitely go for these kind of robots. And what if your robot can lure you into liking things, liking in that very specific sense of the like button, based on herding behaviors continuously being tested in the clouds? Now, obviously, these iRobots, however smart they are not human. They may be autonomous in the computer science sense of that term and targeted, but they have no conscious, let alone a self-conscious so far. The question is, who is in control? What is the business model here? And how is that going to affect your privacy? 30 seconds. Assume that we are going to share within the coming 10 years, our on-life world, that new breed of on and off life. World with robots that combine data-driven agency with morphological agency. Morphological agency will be that they're very soft and elegant robots, very nice to deal with, very good user experience. Now, to have anything that even resembles privacy, we will have to learn how to intuitively guess what these guys and girls, or whatever it is up to, what they will share about us with whom. And I would dare say that to gain back something like our privacy, we would have to dare to take an intentional stance towards them. That means we will have to realize that they are continuously anticipating us. Even though they are not human, they have no conscious and no self-consciousness. But if we do not learn how to take this intentional stance, then I believe we're in deep trouble. This is just, I found this. This is an artist who gave an exhibition in New York City. She imitates robot movements, but she does much more than that. She imitates a robot that is imitating human movement. Now, it's this double anticipation. I'm trying to anticipate how you're anticipating me. That is core to our humanity. Philosophers call that double contingency. Okay, you can do that with movement. Can we ever do that with our thoughts, with what makes us as subjects, as agents, as human agents? Okay.